My name is Varshney. I'm from the Department of Electrical and Computer Engineering, and I'm also affiliated with the Coordinated Science Lab and with Beckman. My background is primarily in information theory, so trying to prove limits of performance of various systems. And I've recently been trying to think about this questions of scalability, privacy, and reliability in peer grading, often motivated by large-scale MOOCs. Okay, so if we think about scalability of MOOCs, one of the main restrictions is the ability to assess. Especially for formative assessment, it's important for students to get feedback so that they can achieve educational mastery. And assessing these open-ended tasks often provides greater insight than closed-ended questions like multiple choice. But these are often hard to assess automatically. There is a lot of work ongoing in machine learning to be able to do this, but perhaps we can use other students in the class to do this in a scalable way, right? And so that brings forth this idea of peer grading. Okay, can we use the students that are in the class to grade each other? Okay, but this brings about a variety of other problems. Students, almost by definition, do not have strong expertise in the content they're tasked to assess, since they're students in the class. But maybe if they're given standardized rubrics, they can actually answer smaller questions about the submitted results. So maybe I can assess, if I'm a student in a computer science class, maybe I can assess whether a single line does what it's meant to do, or is this rough structure appropriate, or the inputs and outputs appropriate, things like that. Okay. So maybe we can decompose the assessment task into smaller tasks. A second issue is one of reliability. These peer graders might not be super motivated and might not do a good job. Okay. Further, they might have bias. And then also there might be concerns about privacy. There might be ethical, regulatory, or legal reasons to preserve some level of privacy of student work, even from their peers. Okay. So can we actually have peers grade something that they don't really understand and they're not given full access to either because of privacy constraints? And they're not motivated, so they're maybe acting unreliably. Okay, so that's the question. Is this something that's possible? And there's a strong analogy to privacy-preserving crowdsourcing with unskilled and unreliable workers. Okay, so that's the question we wanted to ask. And as it turns out, one can draw on ideas from coding theory, the study of error-correcting codes, to be able to actually do this in a certain sense. Okay, so the first thing we try to do is introduce artificial noise to perturb the data that's being assessed. So here in this example, I'm just showing an image labeling because it's easier to show on a slide, but one can think about the same things for assessment tasks. Okay, so we're trying to figure out if this dog is, which breed of dog this is. Is it a basset hound or a bloodhound or a Saluki, or what is it? Okay, and so most people don't know the difference between most breeds of dogs. Great, so they can't do the task, so they're unskilled. And further, we've added noise, so we can't even see the dog so well. Okay, so what we're going to do is introduce a coding-theoretic approach. So we're going to cast queries being posed to the peers as a code word. And so it might be a simpler question like, is the dog small or large? Is the nose snub or long? Are the ears pointy or droopy? Questions like that. And they'll be posed to the peers, and then there'll be some information aggregation done, some kind of decoding algorithm, and hopefully we'll recover the true class, despite the fact we're introducing extra noise, despite the fact the peers are unreliable, and despite the fact they don't know exactly what they're doing. Okay, so that's the rough idea. And so we've developed some codes for actually doing this, and they seem to have much better performance than simpler approaches like majority voting. Okay. The main tension in this kind of problem is between information aggregation for task performance and information aggregation for breaking privacy. Right? So if if the peers work together, they can actually try to break the privacy that we had introduced by introducing noise. Okay. So you can think of that as what people call a collusion attack. Okay. So here on the right, you're taking images. The different workers are working together to try to figure out the true data. On the other hand, here they're trying to just figure out the labels. Okay, so as it turns out, there is a fundamental tension here. And in particular, for a given level of privacy protection, we can drive error probability down by increasing the number of peers to whom the queries are posed. And as one might expect, for greater stringency of privacy requirements, it's harder to attain small error probability. But this does work a lot better than simpler techniques like majority voting. Okay, so so we've tried to cast this in a kind of mathematical framework at the moment, but going forward, we want to try to bring in a greater sense of realism into the models and understand whether we can use these coding theoretic techniques in actual practice. So that's kind of the direction we're going in.